we are going to do today, and we will see the Arduino from the basic today itself. Okay, so let's begin. First we need to go to the Arduino software what we have downloaded. Okay, like the model 18 1.8.15 I have downloaded. Okay, so after opening this one, we can find the somehow interface like this. Okay, this is the Arduino software monitor. Here we need to write the code, and after writing the code we can execute it. Okay, we can give it to the Arduino Uno board, and those code can be uploaded to the Arduino board, and it can be compile. After compiling we have to upload, because compiling is what? Compiling is checking the error, if there is an error or not in your code. If there is any error, the code will not be able to compile completely. Okay, fine. And after that we need to upload it. This is the upload button. Okay, for compiling, after writing the code, we need to save the code first. Okay, once you save the code, we can check whether the code is correct or not. For that we need to compile it. This right sign you can see, right? This is shortcut method, or you can go through the sketch also. Just click on the sketch. Here you can see the compile, right? So here also you can run your model, and after that you can upload. So these are the short keys actually given here. This is a compile and this is the upload. Okay, compiling is what? Checking the error, if there is any error or not. If there is no error, then you are free to upload your program to the Arduino board. Okay, so once you click this button, you can able to upload the program. Okay, like that cable which I have shown, right? How to connect the Arduino boards with your laptop in the previous video if you have seen. So you will be able to understand how to connect your Arduino board with the laptop. Okay, so after connecting the cable, you need to just compile and just upload it. Okay, so this is the things what you have seen. File, if you go to the file, there is a new, you can go to the new window, like and after that you can open, if any project you have written, if any code you have written in the software, you can open it from here itself, right? Okay, so now open the recent one, the recent which you have done just now, if you want to open. Okay, the sketchbook. Then what are things you have made the project, this will come in the sketchbook itself. Okay, like what are the codes you are writing. Okay, all the codes are going to save in the sketchbook itself. Okay, fine. So this is a close, save as. Okay, this is a print, you can print your code also and quit. Okay, after that we'll go to the edit, and edit is what? Edit is for undo, redo, copy from HTML, paste. Okay, so we can do these commands, we can use these commands and we will see. Okay, fine. And sketch I have seen already, I have showed already. This is a compiling and uploading can be done using this sketch. Getting? So there is a shortcut method also. And one more thing I have to tell, the tools, what the tools we have see here. The tool is very important factor of this software. Very important thing we have to see. So the first thing we have to see whether our Arduino Uno is selected or not. Okay, for that what you need to do? Go to the board manager and then Arduino AVR boards. So what we have selected here, Arduino Uno, because we are going to use Arduino Uno, right? If you are in case in the future, if you want to use any other boards, you can use, you can select those boards and you can do the programming. Getting? Fine. After that you have to see which port you have connected, because I do not have any software right now. So if you just connect this your board with the help of USB cable, you can see the port here also. Fine. So these two things we need to check. This is compulsory. Okay, before uploading your program in the software, in the hardware. Getting? So let's start with the program first. So the thing what we are seeing here, it's an interface for Arduino software. So there are two fields in the program. The syntax is very simple. This is the syntax of Arduino. Okay, so here what we see is void setup and void loop. There are two sections. Okay, and above this section we can see one space, like where the cursor is blinking. So that is called a global declaration section. So what is that global declaration section? In the global declaration section, what we do, the pins, like today in this video we are going to do a project based on LED blinking, right? So we are going to check whether the LED is blinking or not. Fine. So this is a very basic program. Okay, so very first thing in the Arduino we have to learn this thing. Okay, after that we can go, we can do any other projects using other sensors and everything. Fine. So this is the basic thing. We have to see the basic thing, how the basic thing has been can be executed using this Arduino software. So after that we can do step by step, we move up, and we will see the various projects in this Arduino software. Okay, so this is the today in this video we are going to do a project on LED blinking. Okay, so because LED have two terminals, right? One terminal is a positive terminal and another one is the negative terminals, right? So positive terminal is always a long one, the long pin, which you can see in the Arduino. Okay, and the smaller one is going to be your negative terminal. Okay, just for example, you can search it from the internet also. Fine. So what we'll do first, this section where the cursor is blinking in the code. So this is called global declaration section. Here we need to define which pin numbers we are going to use. Okay, so only in this section we define which pin numbers we are going to use. Like in the Arduino Uno board, pin configuration has been shown to you guys, right? So there are various pins, right? So which pin we are going to use here, that pin we have to mention in the global declaration section. Got it? So what are the pins we are using? Those pins we have to show here which pin we are using. So I'll just use a code for this. Like first we need to write int, then name of the pin, like anything you can write, LED pin I'm just giving. Okay, name of the pin, LED pin, then equals to pin number 13 I'm going to use here. That is a digital pin. Why we are using a digital pin? Because see, your LED, it works on LED, digital powers like zeros and 5 volt. If you give 5 volt, LED will on. If you supply 0 volt, LED will off, right? So that means there's two scenarios, right? Only two scenarios. That's why we're using a digital pin. So LED is going to be a digital. It is going to operate digitally. Okay, fine. Because LED works on only two signals, 0 voltage and 5 voltage, right? This thing, void setup. Now we will come to the void setup. What we will do in void setup? Here in the void setup we have to define like whether the pin which you have selected, it's a input or the output pin, right? So I will just write here's the code which you have to use for the defining the whether the pin is output or is a pin mode, PIN. One more thing I will tell, this Arduino software is a programming is a bit of case sensitive language, which we have to take care of the words we are writing here. Pin mode we will write. See, once the keyword pin mode you have written, see the color has been changed, right? That means this is the color, it's correct one. I'll just first show you. If I don't use this capital M instead of capital M, if I use small m, then just I'm using a small m. So now this is not changed, right? That means what? This is not a proper code. This is a keyword we have to use. This is a case sensitive language, MODE. Now we can see the color has been changed, right? So here we will define what kind of pin is it. Is it an input or output? So this is what we define in a void setup loop, correct? So let's define LED pin which you have chosen. Just write that LED pin, it's a output, right? Output should be written in the capital output, as I told, because this is a case sensitive language and semicolon is a must. Semicolon we have to give. Fine. So this two phases is done, right? So what this one represent, which I have selected just now, the yellow one, this represent the comments. Like if you don't understand why you have written this code, you can pass some comments, right? To just in order to remember something. Like this one, see, put your setup code here to run the code. I'll just write what I'll write, just for keeping in mind that we have to use this one, pin mode defined. I can write anything, that's not a problem. You can comment, you can write in any word. Output pin mode, output pin you write, it's just a comment, output pin. Okay, what we're deciding, it's the output pin we have decided. See, pin number LED 13, what we see here, it's assigned to pin number 13. Okay, and LED pin is a output, it's a output pin we have decided. In pin mode we have to define this one. Okay, this is a void setup. What are the pins we are using and what is job of the pin? It's output or input? It's a output right here. Fine. Next we'll go to the void loop. Okay, so this, if you want to just pass a comment, you just to give a 2 slashes and just write something, write anything, so that you can remember why you have written that code. Fine, got it? So I'll just remove this one. It's not required. If you just want to keep it, you can keep, otherwise you can remove also. Okay, fine, I'm just removing it. Okay, next, what is the void loop? What we do in the void loop, In void loop we will write the output. Okay, we will supply power to the LED. Like how we will supply, what we will write, for that we will write, because this is a digital output, so what we will need to write, we need to write digital write, digital write, WRITE, digital write what, LED pin, right? Your LED pin is going to be high. High means what? We are sending 5 voltage 5 volt we are sending it to LED. Getting? High means what? Sending 5 voltage to the LED. Then we will provide some delay. Why we are sending delay? I'll just tell you. Delay 1000. Here the delays are represented in the milliseconds. Okay, so that's why I'm writing 1000 milliseconds. Okay, 1000 milliseconds means 1 second itself. Okay, here the 1000 milliseconds is represented as a 1 second. Getting? If you're giving 2000 milliseconds, that means it will wait for 200 2 seconds. So I'm giving 1000 milliseconds. That means once the LED will start blinking, once the 5 volt is applied to the LED, that is become high, LED start glowing, and it will glow up to 1 second. Getting? That means delay means it will glow up to 1 second. Then again digital write, LED pin low we will do. Delay, again delay we have to pass. This delay again 1000 milliseconds. Okay, this is done. This is the programming of this glowing the LED. So I hope you guys understood. So first what we did, we have defined an integer LED pin. So in this session, this is called global declaration section, where we have defined which pin we are using. The pin numbers we have to define here, right? Which pins numbers we are using, because we have so many pins numbers, like analog pin numbers start from 0 A0 to A5, and this is the digital, because digital output we are looking for the digital output, right? So that's why I have given pin number 13, because it's a digital output. And in the void setup, we have to define what is the job of the pin. Is it going to be like an input or output? So LED pin here going to act as a output. The names LED pin you can give any name, that's not a problem. Okay, fine. Okay, or has defined include also you can add. That's instead of integer, this int, instead of this int, what you can add, has include you can add. Okay, fine. And then next let's go to the void loop. Here what we will do, we are giving a supply to the LED. Like first what I am doing, digital write, I am writing 5 voltage. High means what? Giving a 5 voltage to the LED. Correct? And then we are giving a delay. That means your LED will glow for 1 second, like 1 millisecond. 1000 millisecond means what? It is 1 second. The LED will glow for 1 second, and then digital low, digital write, LED low. Low means what? Here LOC, it is not showing the proper way. So I'll just need to write in the capital. Fine. So now, fine. So digital write, LED pin low. That means LED will off, and till how much time it will off? It will off for 1 second. Again the loop will be continuously keep on going. So what we need to do after this, we need to save it. So for Control S we can press for saving, right? So once you press Control S, it will one window will open, and there we need to save the file. So this is the first programming. I'll just write 001. You can give any name, that's not a problem. 0001. Okay, LED pin. What will give? LED pin. LED. Just give a name. LED blink. Getting? Save. After that, we just need to save. So once we are saving, we can see the name here, right? 001 LED blink. Fine. So this code is saved. See, we can see here, right? Now I am going to compile it. Ready? Compile it. Compilation in the sense we are checking whether this code have any errors or not. Okay. So if there is an error, the something will come out. I will show you by showing giving some error also in the code, and we'll see whether it's able to compile or not. Okay. So just wait for the code to get compiled. Once the compilation is done, we can upload it in the Arduino board. Okay, and I will show you how to do the connections also. Okay, because connection is very important in the Arduino. For that, that's the code to compile first. Compiling sketch. While compiling, we are not supposed to do anything, any actions to be performed while compiling. Thus the code get compiled first. Just this screen. Let's finish it off. It's getting compiled now. It's checking for the error. If there is any error, the code will not compile. Okay, and the error code cannot be uploaded in the Uno board. Okay, if there is an error, done compiling. See, so we can see the compiling has been done now. So after that we can upload it directly. So here no need to upload because we do not have any hardware. So as I said, we are going to use online simulators to because I don't have any hardware right now. So we are going to use a online simulator for it, right? So for that, what we need to go to the Google first. Go to the Google because we need to see the output is working or not, right? So we are going to use a Google. Go to the Google first, and once the Google is open, what we will type here? Let's the Google open first. So here we will type Tinkercad. Okay. So Tinkercad is a platform where we can perform online simulators for the Arduino. Okay. Not only for Arduino, we can do a 3D printing, 3D designing and everything we can do here. So once this is open, you just need to go into click on the Tinkercad. Just click on the Tinkercad. So once you click on the Tinkercad, you can see various the platforms somehow interface like this. Let it open first. It's an online simulator tools which we use to see whether the output is working or not. Fine guys? Okay. So let this tools open first. Okay. So new design. Okay. I need to go to the new design. Create new design. Just click on it. Once you click on it, you can able to create your design. Okay, I'm sorry. So 3D design is open. I need to choose a socket here, not the 3D design, because we are not doing 3D design right now. You need to click on the socket. Tinkercad from mine to design. Okay, let this web page open. Okay, wait for some time. Okay, now we need to go to the circuit because this is Arduino is totally based on circuit, right? Just click on circuit. Once you click on circuit, you need to create a design. Let's create new design. Just wait for some time. Once this one is open, you will find interface somehow like this. So we will do fast to just do the simulation. Let the interface open. Okay, so this kind of interface we will find out. Okay, once this Tinkercad opens for the circuit. Okay, so here we can see various components given. So we can use these components to execute our model, execute our project. See, there's so many components are given, right? So we can use anyone. So because right now I'm going to use LED, so I need to choose LED first. LED I have chosen. Okay, so which color LED you can change the color, name, anything you can change if you want. If you want to green, you can go for green. I need resistor also for this. I will tell you why resistor we have to need. Okay, and then we need Arduino board, Arduino Uno. Arduino Uno will be required, right? Because Arduino Uno we are using. Arduino Uno I have using, and I have to also use just delete this one because I have taken two. Okay, and I have to choose the breadboard. Fine, I have chosen the breadboard. So first I will tell you about the breadboard. this breadboard, we can see this two slots, right? This is the first slot, the whole thing, and from A, B, C, D, E, this is the first, this all are connected in a series manner, so they are already short in a series manner. There is a wire connected inside the internal connection, the wire is connected like straight for the series. Okay, so all the wires connected like straight, so that means this all holes are shorted. Okay, getting? And here in the this session, here all the wires are connected, in the horizontal way, like they all are holes are sorted in the horizontal way, getting? And these holes are sorted in a vertical way, so all holes are connected through the wire, one single wire, getting? Like this holes also connected in the, and here again this is a horizontally connected, these all wires are, all holes are sorted by a same wire, getting? So you put anywhere. Let's do the Arduino connections now. So first we need to put the LED here, right? So these two ends we can see here, right? One is a little tilted one, and this one is a straight one. So this one is a positive anode, and the straight one is a cathode. That means it's a negative, getting? So the tilted one, okay, the curvy pin what we can see here, it's a anode, getting? Just connect, that is a positive, and this is a resistor. What we have to choose is a resistors of 330 ohm resistors we are going to choose, because 330 ohms resistors are used for to give a to supply a voltage to the resistor. What is the job of the resistor? Resistors are used to resist the current value, because I am supplying a 5 volt. Just imagine a 5 volt or 12 volt I am supplying. So 12 volt is going to be a more for this LED, right? This LED won't be able to tolerate 12 volt. So that's why in order to do that, we need to connect with the resistor. What the resistor will do? Resistor will stop. The resistor will stop the current following towards the LED, and it will reduce the current value, right? It will reduce the current value. The resistor means resist the current. Ready? Fine. Just click on the resistor. You need to change the resistor value, because here second. Okay, resistor what you have to choose here. Here we have to write 330 ohm resistor. Okay, 330 ohm. See, it's a kilo ohm and ohm, right? So here we are going to connect it. Why we are connecting the resistor? So that if the 12 volt is supplied from the Arduino, so 12 volt cannot be tolerated by the 5 volt LEDs, right? So the 12 volt will be, the 12 volt current will be voltage current. The voltage what is passing by 12 volt, the resistor will stop the current up to 12 volt supplied by the Arduino, and it will resist. So only 5 volt will be supplied to the LED. Otherwise, if you supply 12 volt directly, the LED will blast. Okay, it will stop working. It will get damaged. Okay, that's why we have to use resistor, so that the voltage can be driven in the 5 volt form. Getting? Okay, just connect here where we have to connect, because pin 13 we have to connect, right? Pin 13 we will connect directly, pin 13, and this one will go to the ground, because this is negative. And again this ground we have to use. See the ground I am using, I am going to connect anywhere, because these all are sorted, right? So this is the ground pin connected to the ground, getting? And this is the 5 volt supplied by the pin number 13 through the resistor. Getting? So this is the connection of the LED. Fine. Then later we have to do the coding. So same coding we have to use, because we have compiled this coding. Just copy this code with the help of Control C. Okay. Then come here and then paste the code here. So here are various codes we can use: block codes, text code, text and block codes. So we have, because this is text codes, just click on the text. Just click on the text. Okay. And just remove the previous one. I don't know what code is it, just delete it. and we'll just use our code, Control V. Okay, once this is done, we will start simulation and you'll see the output now. Getting? Okay, have you seen the process? We need to copy the code from the Arduino software, okay, and we have to paste it over here. Getting? Just click now. Once you click, you can see the output LED is blinking. See, it's blinking for 1 second, then off. See, again blinking and off for 1 second or on for 1 second. So this is the video for today's. Okay, I hope you enjoyed this video, and in the next video we'll be coming with the other things. Okay, and we will see how the other projects also can be executed using this model. Thank you for watching this video. Thank you.